Light travels down a fiber optic cable by bouncing repeatedly off the walls. Each tiny photon, particle of light, bounces down the pipe like a bobsleigh going down an ice run. Now, you might expect a beam of light, traveling in a clear glass pipe, simply to leak out of the edges. But if light hits glass at a really shallow angle, less than 42 degrees, it reflects back in again, as though the glass were really a mirror. This phenomenon is called total internal reflection. It's one of the things that keeps light inside of the tube. The other thing that keeps light in the pipe is the structure of the cable, which is made up of two separate parts. The main part of the cable, in the middle, is called the core, and that's the bit that light travels through. Wrapped around the outside of the core is another layer of glass called the cladding. The cladding's job is to keep the light signals inside the core. It can do this because it is made of a different type of glass to the core. More technically, the cladding has a lower refractive index. The simplest type of optical fiber is called single mode. It has a very thin core, about 5 to 10 microns in diameter. In a single mode fiber, all signals travel straight down the middle without bouncing off the edges. Cable TV, internet, and telephone signals are generally carried by single mode fibers, wrapped together into a huge bundle. Cables like this can send information over 100 kilometers. One of the ways to show the total internal reflection that occurs inside of the fiber optic cables is to use jello and a laser pointer. Once you find the correct angle, the light from the laser pointer is reflected completely back into the jello. This is an example of complete internal reflection. That's all you need to know about fiber optic cable. Thanks for watching.